Hello everyone. I myself Professor M. N. Jadhav from KKWAK Polytechnic Nasik. In this session, we will go the introductions to Zener Diode. Now, what are the unit outcomes? Let us see. In this, we will learn the constructions and the concept of Zener Diode, then the symbol of Zener Diode, the VI characteristics, that is voltage and current characteristics of Zener Diode. Then next, we'll go for Zener breakdown concept, applications of Zener diodes, and the comparison of Zener diode and semiconductor diode. Now let us see what is the definition of Zener diode and what is exactly the meaning of Zener diode. A Zener diode is a silicon semiconductor device that permits the current to flow in either forward or reverse directions. The diode consists of a special and heavily doped PN junctions designed to conduct in the reverse directions when a certain specified voltage is reached. That means it is identical to normal semiconductor diode in constructions, which having PN type material with one junctions, but it is heavily doped. The Zener diode has a well-defined reverse breakdown voltage at which it starts conducting the current and continuous operating continuously in the reverse bias mode without getting damaged. Additionally, we can say that the voltage drop across the diode remains constant over a wide range of voltage, and this is the feature that makes the Zener diode as a voltage regulator. That means we get the constant output, but this has happened only in reverse bias conditions. Now, in short, we'll see that the Zener diode is heavily doped semiconductor device that is designed to operate in the reverse directions. This is the symbol of Zener diode, which having two terminals, anode and cathode. Now let us see, this is the practical setup to find out the voltage and the current characteristics for the Zener diode. Here we are observing the Zener diode is connected in reverse bias conditions. That means the anode of Zener diode, it is connected to the negative of the battery, and the cathode is connected to the positive of the battery. What we learn or what I stated just now, it operates in reverse bias and gives us the constant output voltage. That's why the diode is probably, when using as a regulator, it connected in reverse bias conditions. Now let us see the waveforms or the VI characteristics of Zener diode. Basically, it is going to operate in two ways. First is forward characteristics and the second is reverse characteristics. Now let us see in forward characteristics, as we know that anode of the diode is connected to positive of the battery and the cathode of the diode is connected to negative of the battery. Here, if we are observing that in forward bias conditions, the waveforms for this diode, they are identical to semiconductor diode. And when it is connected in reverse bias conditions, that is anode is connected to negative of the battery and cathode is connected to positive of the battery, at that time, it operates or gives the outputs in the third quadrant as shown in the figure. Okay, basically we are observing quadrant number 1 and quadrant number 3. So let us see from the figure itself. In first quadrant, it behaves as an ordinary diode and gives its characteristics. And in reverse bias conditions, we observe here two states, that is one is called as Zener breakdown and second is avalanche breakdown. Now we have to learn what is the concept of Zener breakdown and avalanche breakdown when it is connected in reverse bias. Now see here, what is avalanche breakdown? We learn the concept. Avalanche breakdown, it is going to occur both in normal diode, that is semiconductor diode, and Zener diode. But it is going to occur at high reverse voltage. When a high value of reverse voltage is applied to the PN junctions, the free electrons, they get sufficient energy and they accelerate with high velocities. Means they start their movements. The free electrons moving at a high velocity, they collides with each other and generates more and more electrons, due to which the continuous collision, it is going to occur. And the free electrons, they are generated as a result of electric current in the diode rapidly increases. Means After the collisions of these electrons, the current is going to increase rapidly. Okay. So this sudden increase in electric current, it may permanently destroy the normal diode. But this is not the case for Zener diode. As Zener diode is heavily doped and it is going to operate under the avalanche breakdown, and we can sustain the sudden spike of currents. Okay. So this avalanche breakdown, it is going to occur in Zener diode when the Zener voltage is greater than approximately 6 volt. Now in the previous figure just we saw that the characteristics curve for avalanche breakdown is not as sharp as the Zener breakdown. Now the second concept related to Zener diode is called as the Zener breakdown in Zener diode itself. So when again it is going to operate in reverse bias conditions. Now we have the theory for this one. When the applied reverse voltage reaches closer to the Zener diode or Zener voltage, the electric field in the depletion region, it gets strong enough to pull the electrons from their valence band. That means we should be familiar with the concept of energy band concept of semiconductor devices. Okay. The valence electron that gains sufficient energy from the strong electric field of the depletion region and breaks it free from the parent atom. At the Zener breakdown region, a very small increase in voltage results the rapid increase in the electric current. If you are observing the VI characteristics of Zener diode, they are sharp in nature. Just I will show you the characteristics again. Let us see this graph. This is the VI characteristics as you will learn the meaning of avalanche breakdown and the Zener breakdown. Now we will see the next point. These are the general specifications for the Zener diode. The first one you can say, as usual, for every semiconductor diode, the first point is Zener breakdown voltage. It may be forward breakdown or reverse breakdown voltage. Second, we can say that the maximum Zener current, minimum Zener current. Next point is the power rating, the temperature stability of the Zener diode, the voltage tolerance capacity of the diode, and lastly, we can say the resistance of the Zener. So all these are nothing but the Zener specifications, and they can depend on diode to diode and its value. Now next, we'll see some little bit applications of Zener diode. The very first and important application that Zener diode we are using as a voltage regulator. Voltage regulator is nothing but we can use to give the constant output voltage. And this is going to achieve only when the Zener diode is connected in reverse bias state. The second application is Zener diode in overvoltage protections. It is used to protect the devices from overcurrent and overcurrent or current flows through the components. And the last application you can say that it is the Zener diode is also used as a clipping circuits. That means it is used to modify or the shape of the AC waveform, that is a clipping circuits. Means partly if you are expecting to remove the part of the waveform, the Zener diode is going to use for the clipping of that waveform or removal of the waveforms. Here, the comparison of PN junction diode, that is semiconductor diode, and the Zener diode is given. The first point, the PN diode is a semiconductor that conducts simply in the directions in the forward bias conditions. But whereas the Zener diode, it is going to conduct in forward as well as in reverse bias state. The second point we are going to observe, the junction can be damaged with the reverse current effect. That is the case for PN diode. But this is not the case for Zener diode. It is not going to damage the junctions because it is heavily doped. The next point, that the junction can be damaged with reverse current effect. Just we learned or we discussed here. The next point is that the doping level of the PN junction diode is low, whereas the doping level of the Zener diode is very high. Then the junction in semiconductor diode, it occurs only at higher voltage, but in Zener diode, we can say that the breakdown is going to occur at lower voltage. The PN junction obeys the Ohm's law, whereas we can say that the Zener diode is not going to obey the Ohm's law. And the last point, that is nothing but basically we are using, and mainly we are using the PN junction diode as or for the purpose of rectifications, whereas the Zener diode we are going to use as a voltage stabilizer or a wave shaping circuit or for protections, and basically it is used for the regulator as a regulator circuits. So these are nothing but the little bit information related to our Zener diode, in which we learn the points, symbol, characteristics, working principle, and its operations. Thank you.